Rational equations. All right, lesson 78 is rational equations. Rational is like fractions. Sometimes it means we have x in the denominator or like x plus 1 in the denominator. People confuse this with adding, okay? So the main thing you need to notice is there is an equals sign, okay? So if it said to add, you would get common denominators and there would not be an equal sign in the problem, okay? Like if it just said to like subtract these two pieces without the equal sign, that would be different, okay? Common denominators. This has an equal sign. And so the way we do these problems is we cancel the fractions. We fraction bust, okay? So we're going to multiply everything by the common denominator instead of getting a common denominator, okay? We cancel them by multiplying by whatever 4, 3, and 2 go into. What's the smallest number 4, 3, and 2 go into? So we're going to take this entire equation. Again, there is an equal sign. That's how we know to do this. And we're going to multiply by 12. So when I multiply this times 12, I'm getting 12z over 4. Okay, so in my head, I'm just doing how many times does 4 go into 12? 3 times. And sometimes, you guys, once you get better at this, you can do it that way, like how I'm showing you. Sometimes I actually write down, I am multiplying each term by 12, okay? So that way you can watch what's happening. This goes in 3 times, and the 3 multiplies to the z. So I have 3z. All right, and then I have a minus sign, okay, minus in the problem. Now I do 3 goes into 12 how many times? 4. And the 4 multiplies to the 1. This is 4 times 1, so that's minus 4. All right, how many times does 2 go into 12? And it multiplies to the z, and we always put the number in front of the variable, so you want to put 6z. Okay, so now no more fractions, and this problem is much more doable. Okay, so I multiply by the common denominator. I'm going to subtract the 3z so that all of my z's are on one side. Okay, I have a negative 4 left here. And then 6z minus 3z is 3z. And then I divide both sides by 3. So my final answer is negative 4/3 equals z. All right, let's do another one. Okay, 2x over 7 minus 3x over 2 equals 1/3. So again, as long as there's an equal sign, we can cancel all the fractions by multiplying everything by the common denominator. This is legal, guys, because you're allowed to multiply to one side and the other side. So if I just had an expression, I just want to show you this, okay, because people get this confused. Say that this was the problem right here. First of all, the directions would not say solve, okay? You cannot cancel these fractions over here because there's no equal sign. I can't just multiply by something unless it's top and bottom. Okay, I could get common denominators here and multiply by 2 over 2 and 7 over 7, okay, but I can't cancel the fraction. Only when there's an equal sign can I cancel the fraction, okay? All right, so what do 7, 2, and 3 go into? I agree, 42, all right? So we are going to multiply every term by 42. And I like to write it there, but you can also just do a big set of parentheses and show 142 that you're multiplying to the entire equation, okay? How many times does 7 go into 42? Okay, and then this multiplies right here. So 6 times 2x is 12x. How many times does 2 go into 42? 21. Then I have to multiply the 21 times the 3x, and don't lose this negative sign. So that would be 63x. And then how many times does 3 go into 42? 14. And we multiply by 1. All right, which is just 14. All right, 12 minus 63 is negative 51x. And then I would divide by negative 51 right here. And that does reduce. I believe 7 goes into 51. No, it does not. Does that reduce? I don't think it does. JK. So this is just 14 over 51. The negative can go on the top or the bottom. All right, last one. This one has something a little different in it. There are binomials in the top, okay, instead of just single numbers or single variables, okay? So I have 4, 2, and 10. You take the biggest number, 10, all right, and you write out like, okay, obviously 2, 4, 4 doesn't go into 10, right? The next multiple of 10 is 20. So did they all go into 20? Yeah. All right, so I'm going to put a 20 next to each term. Okay, or you can do a big set of parentheses and you're multiplying by 20. All right, how many times does 4 go into 20? 5 times. Now, you have to distribute this. It's like there are parentheses, okay? So this 5 has to multiply to the x and to the 1. So this would be 5x plus 5. All right, how many times does 2 go into 20? 10 times. Then multiply to the 3. There is a minus sign, so it's minus 30. And how many times does 10 go into 20? 2. Yep. And then make sure you are distributing this too. So this would be 4x minus 18. And then we would solve. So this would be 5x minus 25, because 5 minus 30. Then I would subtract 4x from both sides and also add 25 to both sides. So this would give me just 1x equals 7. Okay. All right, let's try some fraction busting on the whiteboards.